Today we're going to look at lesson 2.3a, the first part of section 2.3. We're talking about linear functions and slope-intercept form. Our targets are to calculate slope, to graph linear equations, and to write equations of lines in slope-intercept form. So a function whose graph is a line is called a linear function. We can represent a linear function using a linear equation. And there are three ways we can express linear functions. Today we're investigating slope-intercept form. We also have what's called point-slope form and standard form that we will look at in a couple days. So slope-intercept form is y equals mx plus b, where m stands for your slope and b stands for the y-intercept, the point where the graph crosses the y-axis. Slope is the rate of change of your line. We often think of slope as rise over run because we're looking at the ratio of vertical change over the horizontal change. So looking at our lines here, and I noticed on your notes packet some of the lines didn't show up very well, so pause the video if you need to draw your lines in. So the first blue line, we are looking for the slope. Because it is moving upward as we go from left to right, we know that this should have a positive slope. And to actually calculate the numerical value of that slope, we would pick any 2 points where our line is crossing the corner of our graph paper. So if I try these 2 points, I am rising 1 unit and I'm running 2 units. Both of those were in a positive direction. Rising is positive. If we go down, it would be negative. Moving to the right is positive. Moving to the left would be negative. Our second line, notice that our line is moving downward as we go from the left to the right. So we know that this should have a negative slope. And again, we're going to find 2 points where our graph crosses a nice tick mark. And in this case, we have to go down and then right. So because we're moving down 3 squares, we would say our rise is actually a negative 3, but we're still running to the right 2 spaces. For our third graph, picking any 2 points, looking at our slope. We rise nothing, and we run, in this case, the points I chose, we run 2 spaces. 0 divided by anything is 0. So we say this has a slope of 0. It is a horizontal line. So we're not rising at all, but we are running. And for our last graph, for a vertical line, if we pick any 2 points where our line crosses a nice tick mark, now we are rising in this case 3 spaces, but we are running to the left or right 0 spaces. And we cannot divide by 0, so we say this is an undefined slope. All right, so those are the 4 scenarios. You can have a positive slope, your line is moving up as you go from the left to the right. We can have a negative slope, you're moving down from left to right, horizontal or vertical. Horizontal, we'd say the slope is 0. Vertical, we say we're unable to find it. It's undefined. If you're given 2 points instead of an actual graph, you can find the slope with the equation m equals, let me erase some of this here, m equals y2 minus y1 divided by x2 minus x1. In other words, the change in your vertical, your y values, divided by the change in your x values. The one thing to keep in mind, it doesn't matter which point we call point 1 and which we call point 2, but if we identify, say this as our point 1, then this is x1 and that's y1. If this is our point 2, this is x2 and y2. All right, so our slope is the change in y. So we're going to take our y2 value, negative 5, we're going to subtract our y1 value, which is 2. Okay, the change in y. Our x's we have to do in the same order. So if we started and did negative 5 minus 2, then we have to do a 4 minus the negative 10. Okay, so when you look at this, Your numbers here should be coming from the same ordered pair, and your numbers here should be coming from the same ordered pair. All right, simplifying. Negative 5 minus 2 would be negative 7. For our denominator, we have 4 minus a negative 10, which is really 4 plus 10, or 14. And slopes we like to reduce if we can. This would reduce down to negative 1/2. All right, for our second example, again, we're going to take our y values and subtract them. So I'm going to go this direction, negative 1 minus negative 1. Then I have to subtract the x's the same way, 5 minus 6. Simplifying the top, negative 1 take away negative 1 would be 0. Denominator 5 minus 6 would be negative 1, and 0 divided by anything is 0. So here we have a slope of 0. If we had graphed those 2 points, we would have seen that as a horizontal line. Our third example, again, our y values, we're going to subtract. And I'll show you on this one, it really doesn't matter which order we subtract them in. All right, I'm going to do negative 3 minus the 5. Then I have to subtract my x's in the same order, which in this case, they're the same number. And here we do run into a little issue. Negative 3 minus 5 is negative 8, but negative 2 minus negative 2 is 0, and we are not able to divide by 0, so this is undefined. And if you had actually plotted those 2 points, you should have seen a vertical line. All right, I'm going to go back to this first one just to show you that the order that you wrote the points as point 1 or point 2 doesn't matter. So we did negative 5 minus 2. If I had done 2 minus the negative 5, now I'm taking 2 minus negative 5. I have to do my x's in the same order. So negative 10 minus the 4. The only difference is now the 7's positive and the 14 is negative, but it still would reduce down to negative 1/2. All right, so if we are going to graph lines, our first step is to plot the y-intercept. That's the point where we hit the y-axis. And in our y equals mx plus b format, this is our y-intercept. We're going to use the slope to plot some extra points, and then we'll connect those. So looking at our first example, y equals 2/3 x minus 5. Negative 5 is going to be our y-intercept. Notice I took the negative with the number. So we're going to plot a point at negative 5 on the y-axis. Our slope is the 2/3. So we are going to rise 2 and run 3. So from my blue dot, I'm going to rise 2 and run to the right 1, 2, 3. I land there. And I'm going to do that several times. Okay, rise 2 and run 3. Rise 2 and run 3. That gives me enough dots that I can draw a nice line through those. So our last step is to connect our dots and make sure you put arrows on the ends of your line. All right, go ahead and pause the video and try this next one. Checking, let's see, we have a positive 4 for our y-intercept. So we should have a dot at positive 4. Our slope, though, is negative 2. Think of that as the fraction negative 2 over 1. So we're actually going to go down 2 and over 1 to get our next dot. Down 2 over 1, down 2 right 1, down 2 right 1, and draw our line. And it's always a good idea to double check if our slope was negative, like this one. Our line should be moving downwards from left to right. We do have 2 special cases to remember from previous math classes. If we are telling you to graph the line x equals 3, where there's just a single variable, I want you to think of plotting some points that have an x coordinate of 3, like say 3, 0, 3, 2, 3, negative 4, okay? All of them have an x coordinate of 0, so we fulfilled that requirement. Sorry, x coordinate of 3, and we're going to plot those points. So 3, 0 would be here, 3, 2, and 3, negative 4. Notice that they all line up vertically, so this should be a vertical line. If our equation again has just a single variable, this time it's a y, pick some points. We just need to make sure that the y coordinate is -6. All right, so let's say we use 0, 1, -2. If we plot those points, 0, -6, 1, -6, and -2, -6. Now the points line up horizontally. This could have been written in slope-intercept form. Our slope is 0. It's a horizontal line. We have 0 x's and we're subtracting 6. The previous one here, the x equals 3, cannot be written in slope-intercept form because there is no y. And our slope-intercept form has to be y equals. All right, so x equals 3 is always going to make a vertical line, and y equals some number is always going to make a horizontal line. All right, our last topic for today was writing equations of slope-intercept forms. When you're given the slope and the y-intercept, you can simply plug them into the formula for m and b. So if I gave you the question, what is the equation of the line with slope, right? Slope of 6 and y-intercept of 0, 5. That means we have an m value of 6 and our b value is 5. So plugging them into y equals mx plus b, we'd say y equals 6x plus 5. Okay, pretty basic when you're given both values. If you're given a graph, we need to figure out our slope and our y-intercept from that picture. So notice on this one we've plotted a couple actual points. Our y-intercept right here we can identify as being at -3. Our slope we need to calculate. So we can use any two of these 3 dots. I'll just use these ones. All right, so to get from left to right again, we're going down 2 and we're running 4. So our slope would be -2/4, which reduces to -1/2. And again, we can see that here, down 1 over 2. So our equation, y equals our slope of -1/2 times x plus our y-intercept, which is a -3. You can write plus -3, but it really simplifies down to just being -3. Many word problems provide an initial value and a rate of change. These can be plugged into the slope-intercept form for m and b. So initial value is your y-intercept, or your b number. Rate of change is your slope. How fast is it moving from left to right? So in our example, tickets to a concert are available online for $35 each, plus a handling fee of $250. The total cost is a function of the number of tickets bought. Write the equation. So our total cost, I'm going to use a C for that. You can use a Y if you want. It's based on the number of tickets that we buy. And it says the tickets are $35 each. Okay? So as we buy more and more tickets, we're going to be spending, each time we buy another ticket, we're going to be spending an extra $35. So we're really going up $35 for every ticket. Okay? So we could write C equals 35T plus we have a handling fee of $250. Okay? So that's our initial cost. We have to spend that $250. But then we're going to spend $35 on every ticket. And because that's based on how many tickets we have, that would be our slope number. Okay? So 35 was our slope. And the $250 flat fee that we had to pay was our y-intercept. We have to pay that regardless of the number of tickets we're buying. All right, that concludes our notes for 2.3a. Your assignment for today will be 2.3a delta math.